Okay, so we're doing our next unit, which is Math 23. We are in Math 23, which is trigonometry. A reminder, I'm Mrs. Finley, and I will be teaching you this lesson today. So the first thing we're going to do is we're going to do a little angle review. Now, what is an angle? An angle is the space between two lines joined at one point. Okay, and we measure it in degrees, which looks like a little circle like that. Okay, when we look at an angle, it's got different parts. It's got rays. So this is a ray as well. So the two arms are the rays. It has the arc, which is literally the measure of the angle. And it has the vertex. The vertex is that point where they meet, the junction. Okay? We have lots of different types of angles. An acute angle is less than 90 degrees. Okay, acute. It's very acute because it's little, right? So this one, this would be approximately, we'd say around 30 degrees. It's less than 90 degrees. An obtuse angle is larger than 90 degrees. Okay, so we have this, and we might have an angle like this. So as we can see, it's greater than 90 degrees. Looking at this one, looks like about, I don't know, 120 degrees, around that approximately. Okay, we still have our vertexes, still have our rays, and we have our arcs. Okay, so all the parts of the angles are there, it's just the size has changed. A right angle, which we looked at a little bit in the last unit, is exactly 90 degrees. And we like to connote it with that little square. So it's 90-degree angle, right? And we use that when we use the Pythagorean theorem, and we use it when we're going to use our 3 trig ratios, sine, cos, and tan. We've already used tan, but we're going to do a little bit more of that in this unit. A reflex angle is larger than we already have one of those, sorry. It is larger than 180 degrees. So a straight line has 180 degrees if we had a straight line here. If we have a reflex angle that is greater than that, so say this is about 231 degrees, we call that a reflex angle. It still has a vertex, it has an arc, and it has its rays. This is where it's important to kind of look at which direction the arc goes, because it could look like a different angle if we don't look at that way. Complementary angles are two angles that add up to 90 degrees. So if we have, say we have this, it is 90 degrees. If I have two angles that add up to that, so say this one is 50 degrees and this one is 40 degrees, I would say that 50 and 40 are complementary angles, okay? And supplementary angles add up to 180 degrees. So if I have an angle here, which is 80 degrees, and an angle here, which is 100 degrees, they add up to 180 degrees, okay? Again, watch where the arcs are. Look at your rays. We still have a vertex there. And these are just names for different relationships. It becomes important if you're looking for missing angles and that sort of thing. So this is the basic, a little bit of basic angle review, okay? So we're going to do some work with this. Now, angle sums and triangles. In any triangle, the three angles, if you add them up, they're always going to add up to 180 degrees. So no matter what angles I have in a triangle, if I add them up, they're going to add up to 180 degrees. So we can use this to find missing angles. So here, for example, I have a triangle ABC. I know angle A and I know angle B, but I don't know angle C. I'm actually going to make it red so we can really see I don't know it. I don't know. Okay, so that's a mystery. Okay, so I know that the three angles have to add up to 180. So if I add up the other two angles, 30 degrees plus 37 degrees, they add up to 67 degrees. 180 minus 67 equals 113 degrees. So that means that my angle C is going to equal 113 degrees. And you can check that. 113 plus 30 plus 37 adds up to 180. Okay? So if we're missing an angle, and we have two of them, we can use it to help us find the third. So here, it's again an ABC triangle. I have 65 and 75. So 65 plus 75 equals, I can add those up, 65 plus 75 equals 140. So 180 minus 140 equals 40. So that means that my missing angle equals 40 degrees. Okay. Now in this one, the unlabeled triangle, the third one, I have 60 degrees. I have a square in the corner, and a square in the corner means 90 degrees. So I'm looking for angle X. So 60 plus 90 equals 150. 180 minus 150 equals 30 degrees. So my degree here for angle X is 30 degrees. So we can use those angle relationships to find missing angles. Naming angles. Now when we have, there's some conventions for naming angles. If we look at this little picture here, the route we go is from one letter to another letter to a letter. The angle in the middle is always the angle in the middle. So if we look on this picture here, if we're looking for the angle that looks like a little star, we would go A, E, B. So we write that angle would be A, E, B. Okay. If I'm looking for the triangle, I would go C, E, D. Okay, so I start at one and I kind of make a little path. Okay. And if I'm looking for the circle, I go B, E, C. Okay, so you draw that little path and that helps us track it. Now, if I wanted to look for a larger angle, like the star plus the circle, so this Then I'm going to go from A, E to C. You can go the other direction as well, but this one will work, right? And it would be the same as CEA, but we can write AEC, okay? If I'm looking for the circle plus the triangle, that means I'm looking for this one here. I would go BED. Okay? And if I'm looking for, try that one, all three together, so the whole thing, I would go AED. So it's important to kind of track your path when you're looking for conjoined angles like that. We're dealing with a lot of triangles, so it's not necessarily going to be as complicated. Okay, let's practice a little labeling. So we're going to label angle 1 as ABC, angle 2 as KLM, and triangle 3 as PQR. So all we do is we assign a letter to a corner. I want a better color. A, B, C, and we would call this triangle ABC. Number 2, KLM, triangle KLM. Number 3, PQR, and triangle PQR. A lot of times you'll find that the triangles will be labeled for you, and that's important because it's going to identify which angle we might be looking for. So it's going to be labeled for you, okay? But if you wanted to, that's how you would label those. Trigonometric ratios. Now, we talked about this in the last unit when we talked about the tan ratio. So in terms of where opposite and adjacent are, as opposed to hypotenuse. So we're going to take a look at these. Now, the hypotenuse is always across from the right angle. So it's always that longest side. And the opposite and adjacent angles depends on your angle of interest. So where are you looking from? So let's do some labeling. I'm going to use the words OPP, ADJ, and HYP, okay, to label these. So for this first triangle, this is the angle of interest. My hypotenuse is always across from the right angle, so this is the hypotenuse. My adjacent angle, side, is always right next door, so adjacent. And my opposite side is always across, okay? Now, why don't you we should know how to do these from the last unit, so you can pause your video, try the next one, and then come back and see if you're right, okay? So here's my angle of interest. My hypotenuse is always across from the square, the 90-degree angle. My adjacent is the side right next door, and my opposite side is across the triangle. Okay? At any point you can pause it, try it yourself, and then give it a shot. This is our angle of interest. My hypotenuse is across. My adjacent side is right next door, and my opposite side is opposite. So you can see even from those three triangles how those sides change depending on what your angle of interest is. Let's do a couple more. My angle of interest is there. My hypotenuse is there. My adjacent side right next door. And my opposite side is across. Angle of interest is there. Hypotenuse is there. adjacent, right next door, opposite, across. And the last one, angle of interest, hypotenuse. Left out my y there. So my adjacent's right next door, and my opposite is across. Now, there's three, oops, flip on back. Somewhere I got lost. Here we go. There are three trig ratios we can use to help us find missing sides and angles: sine, cosine, and tan. Now, in order to remember the three trig ratios, we're going to remember Soh Cah Toa. And this is a little mnemonic device to help us remember. So what this means is opposite over hypotenuse, adjacent over hypotenuse, and the tan, which we're really familiar with from last unit, opposite over adjacent. So you can see that kind of memory tool for remembering those relationships. Now when we calculate the trig ratios, Soh Cah Toa, and I like to write that everywhere to remember. First we label, and then we can figure it out. So we're always looking for the angle of interest, and then we can label our sides. So in this first one, and it says always round to 4 decimal places to make sure it's as accurate as possible. Okay, so here we go. So our angle of interest is E. So this is going to be our hypotenuse because it's across from the square. This will be our adjacent because it's right next door. And this will be our opposite. Okay, now sine of E, if we look at our thing, it's so it's opposite over hypotenuse. So our opposite is 4, our hypotenuse is 11, and if we go 4 divided by 11, we get 0.3636, so that would round up to 3.6. We don't round that up, sorry. And that's the first one. Cos, and it's cos of U, so find your angle. That's our angle of interest. Our hypotenuse is 31. Our adjacent is 8. And our opposite is 30. So cos is adjacent over hypotenuse, Cah, right? So adjacent was 8 and hypotenuse was 31. So if you write that out, it helps you remember. And when we write our 4 decimal places, it's 0.25806, so we can round that to 801. Okay? Let's do a couple more. Alrighty, so we're looking at tan. Tan is Toa. So, and we're looking for tan of K. So find angle K, that's our angle of interest. Our hypotenuse is 53. Our adjacent is right next door. And our opposite is the 45. So this is opposite over adjacent. Opposite is 45, adjacent is 21. So 45 divided by, it's 28, not 21, 28. So it's 1.6071, 4 decimal places. Okay, now here we're doing another tan. Interesting thing, tan is the only ratio that can be over 1 when we're doing right angle triangles. So there's our S. This is our hypotenuse. Our adjacent is 35 and our opposite is 12. Tan is opposite over adjacent. So it's going to be 12 over 35. Which is 0.342, and that 8 will round up to 9. Okay? Hopefully we got those. If you didn't get the same values, double check your math. Okay, let's do a couple more. We can also calculate the trig ratios of known angles. We're doing these two here, sine and cos. So sine of z, this is our angle of interest. This is our hypotenuse. This is going to be our adjacent, and this is our opposite. So it's following those same rules. Sine was so it's opposite over hypotenuse. So it'll be 5 over 13. So 5 divided by 13 equals 0.3846. And the last one here, cos of A. A is right there. Our hypotenuse is the largest side across from the right angle. Our adjacent is 7.3, and our opposite is 3.3. Cos is Cah, so it's adjacent over hypotenuse. So it's 7.3 over 8.0. So 7.3 divided by 8.0 equals 0.9125. Okay. All right, now we can also calculate the trig ratios of known angles. We are again going to round to 4 decimal places. So for here, what you're going to do is you're basically going to put in that value, and you're going to just find the ratio on your calculator, right? So we know that sine of C is 35, so we're looking for sine of 35. So you're going to put that in your calculator. For scientific, you put 35 in and hit the sine button. For graphing, you actually type in the sine button first and then hit 35, and you'll get 0.5736, rounding to 4 decimal places. I round up that last digit. Okay, so this is the way to check to make sure you're in the right mode. Here, cos C is 35, so it's cos of 35. So you're going to go, again, if you're on a scientific calculator, you put the 35 in and then hit the cos, and it's the opposite for a graphing calculator. So we'll get 0.8192. Okay, so this is a good way to check. And then here, sine of 30, because it's sine of A and A is 30. So we'll put that in, and we'll get 0.5, and it just rounds. Tan of 30, because tan A is tan 30, is 0.5773. Actually, it rounds up to 4. Okay? And you can try these. Let's just try them quickly. Sine of 84, 0.9945. Cos of 10, 0.9848. Tan of 61, 1.8040. And cos of 5.5, which is 0.9954. So check, make sure your calculator is on the right setting so that you can do these properly. Okay, now you have a chance for practice. So it's time to practice these skills, and I'll let you